Okay, welcome to our first core video. So in this video, we're going to be looking at how we solve quadratic equations, specifically by choosing a method that aligns with the structure. So what we want to be doing is we want to be kind of tailoring our solution process to what the question tells us, rather than just looking for like a one-size-fits-all solution to problems. So kind of hook here, you can see down here at the bottom, four quadratic equations, but they're not telling us the same thing. So what I'm going to get you to do is pause the video in a second. And what you're thinking is, what if you go to solve this? Like, what's your strategy for each of those questions? Try to name that method. We don't need a particular name per se. Like, just come up with a name for itself. So, for example, like I see a perfect square, and I would do this. So, pause the video here. Take a minute, and we'll come back. Okay. So couple things we're looking for generally. Now, again, you're not memorizing this checklist. This is just to help you kind of parse through this information. One structure is an isolated square. So if you have a square isolated, why not just square root both sides and move on with your life? Secondly was, what if we have an equation equal to zero and it factors nicely? In that case, you're probably just going to factor and then use your zero product property. Third, what if we could really quickly create a square? Well, then you're just going to kind of create the square, complete the square, and then you're going to move back to the square root method. And then finally, what if we're standard form? What if it's not one of these? What if we're standard form? It's awkward. We don't really have, maybe not real roots. Well, then you can use your discriminant to tell you about the roots and then use quadratic formula if necessary. Okay, so let's dive into a couple questions now. First question is just a quick square structure. So this is a from the hook. So x minus 3 squared equals 25. So to start, you could pause and take a look, like ask yourself, how are you doing this question? Now, in the hook, you did ask yourself the same question, but yeah, like does like that last review help at all? So what do we notice? What method fits best? So for me, as I go through this question, I'm just going to write the question down here first. So I see x minus 3 squared is 25. I see that isolated square. I'm going to square root both sides right now. I'm not going to expand it, distribute, go after a quadratic formula. I'm just going to let the question lead the way. So I get x minus 3 equals the square root of 25. Now, because I introduced the square root, I do have to keep the plus and minus. So plus and minus 5. Then I isolate x. So x is going to be 3 plus or minus 5. That gives me my two solutions. So x is 3 minus 5, which is negative 2, or x equals 3 plus 5, which is 8. And at the end here, I'm just going to collect those answers. So x equals negative 2 or 8, the end. There we go. So I saw a square structure and I let it lead the way. There's one for you at the bottom there. So you could see x minus 5 squared equals 12. I want you to do the same thing. So kind of to yourself as you're doing this, what structure do you notice? How are you going to use that to help you solve the question? Let's try it now. Okay. Here is your solution, right? So you can see that same structure. I recognize a square and I use it in my solution process. The whole idea here is we are trying to be efficient. We actually want to do less math in the question, because the less math we do, the less steps we take, is we're just decreasing our chance of making those mistakes. Okay. So next example here, this is b from the hook. So you see 2x squared minus 7x plus 3 equals 0. So again, we're asking ourselves what structure we doing on us and why might factoring be helpful here. So again, I'm just going to write this question down. So this is 2x squared minus 7x plus 3. So for me, I don't have a square, first of all, but I think I might be able to factor it. Now, factoring, I could go decomposition. That's going to take a while, though I'd prefer to not. I could do a little crisscross shortcut. But for one like this, when I have an A of like 2 and a C of 3, I'm going to go after inspection here. So I know if this thing factors, it's going to have to look like that to multiply to the 2x squared. Now, all I need to do is match the 3. So I can see I'm going to need negative factors, and it's going to be -1, -3. To make this fit, I need to put the -3 with the x and the -1 with the 2x. So now I have it factored. Two things multiply to 0, so I know either the first one is 0 or the second one is 0. So if 2x minus 1 is 0, x is 1/2. If x minus 3 is 0, x is 3. So therefore, x is going to be 1/2 or 3. End of question. Done. So again, you're going to kind of expand that for yourself, try to help with the transfer of knowledge here, and you try that you do examples. So x squared minus x minus 12 equals 0. And again, you are asking yourself, what structure am I noticing and how is that helping me attack this question? So pause it, try it now. Okay. So there's your solution. So you can see ultimately x is going to be -3 or 4. So again, just kind of remember, like, factoring is going to be useful when we set it to 0 and we can really quickly see those factors. Factoring should not be a big process. It should be 15, 20 seconds, factor it, move on. Okay, let's try another one. So here's C from the hook. So you see x squared plus 4x minus 1 equals 0. So immediately, I can't factor this. I don't have a quick way to factor it. My next thought is going to be, can I create a square structure? Now, for me, when I see this question, I look at that B term and it's even, which is helpful. If it wasn't even and I couldn't factor it, I would probably go quadratic formula. But in this case, it is even. So what I'm going to do is I'm going to try to create a square. Now this won't be a ubiquitous strategy, right? Like quadratic formula is also fine in this case. But for me, I'm going to look at this b term, and I know to complete the square, I have to add b over 2 squared. So half of b is 2, and I'm going to square it to complete that square. Now, in doing that, I also have to subtract 2 squared here to keep it balanced. And remember, I have these kind of brackets. So what that does is on the left here, that's going to make x plus 2 squared. I've completed the square. And outside of the bracket, I have -1 minus 4 is -5 equals 0. So now I'm almost at that example 1, right? So add the 5 on both sides. X plus 2 squared equals 5. Square root both sides. X plus 2 equals plus or minus √5. And then isolate x. So x equals -2 plus or minus √5. And that is the answer. Okay. So you can see 1 for you. So x squared plus 6x minus 5 equals 0. So again, look for that structure. Now, that looks like it might be able to factor. So take a look, confirm for yourself whether or not you could, and then solve the question. Okay. So there's your solution. So that one did not, in fact, factor. It looked like it might. It didn't. So I completed the square and solved. Last one to look at here is just a quick contrast. So 3x squared minus 5x plus 10. So I want to solve this. As I look at it, I am going to kind of confirm for myself, hey, that doesn't factor. I don't want to complete the square also because I can see, 1, I would need to factor out the 3, and then 2, that's odd. So I could complete the square. It would be a mess. I do not want to. So in this question, what I'm going to do is I'm going to check the discriminant. The discriminant is going to tell me a story. If I get a perfect square out, it tells me, hey, you probably could have factored. If I get a negative out, it means there's no roots. So I would like a negative out, but we'll just check it. So remember, we know the discriminant is equal to b squared minus 4ac. So here my discriminant is going to be -5 squared, which is 25, minus 4ac. So discriminant is 25 minus, that's 120, which is negative. I don't actually care what it is. It's negative. So what that tells me is discriminant less than 0, therefore no real roots. No real roots. And we're done the question. So solve, no solution. There's no solution here because there's no point at which 3x squared minus 5x plus 10 equals 0. Okay. So final checklist for you to review as you're reviewing this video. So again, we are looking to be efficient in our math here. So before solving these quadratics, anywhere you see a quadratic, whether it's in this unit, later on, or in another course. So before solving, we want to ask ourselves, 1, is the square isolated? If so, just follow the structure. Don't make more work for yourself. Number 2, is the equation equal to 0 and factorable? If so, factor and use the 0 principle. 3, Could you really quickly create a square? If so, complete the square and then go back to 1. And again, that like it has to be obvious, right? Like if there's odd, if there's anything if the vibes of creating the square are off, don't do it. Try the quadratic formula. So 4 says, is it awkward? Maybe it doesn't have real roots. Check the discriminant. And if that discriminant was positive, I would just use that quadratic formula and finish the question. And finally, we'll come back to this later, but does that context restrict the kind of domain of the solutions, or do I need to check it and verify if needed? Okay, that's it. Thanks for watching.